Today, we are diving deep, and I mean that literally. We're going to explore one of the biggest challenges on our planet, trying to predict and manage the water that's hidden right under our feet.
I mean, think about it for a second. How on earth do you manage something you can't even see? This is a massive problem for scientists and water managers everywhere. Our survival literally depends on this hidden resource, but how do we know how much is there?
Because it's completely out of sight, trying to model groundwater levels is incredibly tricky. It's affected by just about everything: rainfall, temperature, how high the rivers are, and none of these relationships are simple, straight lines. If you get it wrong, you could drain an entire aquifer, and that leads to some serious water shortages and environmental damage.
To get around this, scientists use these really sophisticated modeling tools. And today, we're going to frame this as a head-to-head battle. We're pitting two of them against each other, a seasoned veteran against a powerful new AI contender.
So, in one corner, we have multiple linear regression, or MLR for short. This is our reliable, transparent veteran. And in the other corner, we have the newcomer, the artificial neural network, or ANN. This one is complex, it's powerful, and it basically learns kind of like a human brain.
So what is MLR, really? Well, it's a classic statistical method. Just imagine you've got a bunch of data points on a graph. MLR's job is to find the one single straight line that best cuts through and represents the relationship between all those dots. It's fantastic for things that have clear linear relationships.
And then there's the ANN. Now, this is where the AI really comes into play. It's actually designed to mimic the way our own brain's neurons connect and fire. So instead of being told the rules, it just chews on massive amounts of data and learns the hidden, complex, nonlinear patterns all by itself. It's pretty much perfect for a messy, dynamic system like groundwater.
Okay, so we've met our two contenders, but to really see which one performs better, we need a real-world proving ground. And for that, we're going to look at a scientific experiment that was actually conducted in Japan.
The whole showdown took place in the Konan groundwater basin. Researchers gathered 6 full years of super detailed data from 17 different monitoring wells spread all across the region. This gave them a really solid data set to see which model could actually predict what was happening in the real world.
And they fed these models a ton of information to work with. I mean, we're talking everything: monthly rainfall, average temperature, river levels, a whole bunch of seasonal variables, and even the data from previous months. The real challenge was for the models to make sense of all this chaos and spit out an accurate prediction.
So here's how they did it, and it's a pretty classic scientific process. First, they collected all that data. Then, they built a specific model for every single one of the 17 sites, one for MLR and one for ANN. Next, they used the first 4 years of data to train the models, basically letting them learn all the patterns. And then, for the grand finale, they unleashed them on the last 2 years of data to see which one could predict what actually happened.
All right, the models were trained, the data was in, and the test was done. It was finally time to see which of these techniques was better at predicting the future of this invisible, vital resource. So after all of that, who won the fight? Was it the good old reliable veteran, MLR, or was it the complex, brainy newcomer, the ANN?
Well, the results were pretty clear-cut. The original research paper says it bluntly: the artificial neural network technique was superior. The AI newcomer didn't just win, it dominated.
And this chart just shows you the difference so clearly. What you're looking at is the prediction error. Just think of it like a golf score. The lower the number, the better you're doing. Look at the ANN model's error bar. It is less than half the size of the MLR models. It was just way more accurate.
And this wasn't some fluke. This same pattern played out across almost all of the 17 test sites in the study. Time and time again, the AI-powered model just delivered a much clearer, more reliable picture of what was going on underground.
So, ANN is the clear winner. But so what? What does this actually mean for how we manage water in the real world? Why should you care?
While it doesn't mean we just toss the old tool in the trash, the study makes it clear that the veteran, MLR, is still a great, cost-effective option when you're short on time, money, or technical expertise. But for those high-stakes situations, when accuracy is absolutely everything, the new contender, ANN, is the undisputed champ.
And that's really the crucial point here. This isn't just some academic cage match. It's about having better tools for a really important job. Nature's complicated, it's messy, and a simple straight line just can't capture that reality.
The AI model won because it could understand those complex, tangled relationships. And having that clearer picture means we can make smarter decisions to protect these resources for generations to come.
So that leaves us with this final thought. In a world that is facing more and more water stress, the power to see the unseen has never been more critical. Our old tools give us a blurry picture, but AI is starting to bring it all into sharp focus. The real question now is, how are we going to use this newfound clarity to secure our water future?